Hey, this is Dr. Mitchell, and in this video I'm going to walk through how to do kinematic, just basic linear kinematic analysis in Kinovea software. So I've uploaded a video here that was shot in our lab in Kinovea. Just did this in the file and opening, finding it on my computer. And before I get started, there's a couple of things in this setup I want to do just to make sure I get accurate data. So the first thing I'm going to do is going to go to Options and Preferences. And when this opens up, the default is to open up the playback mode. I want to go not to general or memory, but to units. And I want to make sure what I see on the screen here, the time in milliseconds, speed, meters per second, all of this is what I want. And it is. But I got to hit save. Unfortunately, Kinovea's got a little quirk where if I don't do this, it's going to give me the data in pixels, which I really don't want. I want this in actual time units. So I'll hit save there. That's the first thing I want to adjust. The second thing I want to adjust is my video timing. So I'm going to go to Video, Configure Video Timing. Now, I know I shot this video in 240 frames per second. And so I want to make sure that it's aware of that. And you can actually change the default of this if you want, so you don't have to do this all the time. But you may be in a situation where you're shooting video at different frame rates. We shot this, oddly enough, on an iPhone, slow motion, which is 240 frames, but maybe you shot it on a camera that's 60 frames or a standard 30 frames. So we like to shoot things at higher speeds, just make sure we're not missing anything. But again, that's up to you as far as how you want to, the frame rate you want to use. But again, I'm going to set that, I'm going to hit apply, so I'm good there. And then the third thing I want to do, and again, I always do these three things in order, is I want to set a calibration measurement in this video. Now, what would have been great is if I had actually measured, when we shot this, the distance from one marker to another. That would be a really precise measurement. But we didn't do that. It takes time. And so what we do is, in the video we actually have a ruler, this kind of this tape in the background, which we use as our reference. And so I'm going to go down to my line tool. And once I do that, once I appear in my video, I'm going to have a little cursor appear, or a little kind of crosshair. And I'm going to go from bottom to top, or go in the upwards direction. I'm just going to draw a line covering this distance. So there is my bottom. I'm going to draw this up to my top here. This distance, by the way, is 70 centimeters. We have this tape on the wall for a very specific purpose for this, so we know that. And so I'm going to get that right there. And I'm going to right-click on this line. Now, if I want, I can change the color of this. If I don't like orange, I can make it blue or something like that. That's fine. I can make it thicker, whatever you'd like to do. Really, the more important thing is calibrating it. So I need to tell the software that, hey, this is 70 centimeters. So I'm going to go to my calibration. And the default's 100, so I want to change that. And I'm going to make that 70 centimeters. And then it wants to know, hey, what axis is this? Is this your horizontal axis? Is this your vertical axis? Now, for us, this is our vertical axis, so we're going to change this to our vertical. And now it has a precise reference for our subject. Now, to be quite honest, it's not precise. It's a little bit in the background. But because we shot the video so far away from the subject and we zoomed in, we're not going to get much angular distortion. So it's a pretty good reference. It may be off by a centimeter or so, but I'm okay with that. Okay, now let's go back to our tracking. So in this video, we're just doing linear kinematics. So what we're going to do is we're going to track one of these markers. I'm going to pick the hip just because I can. If I wanted to pick the knee, I could, but the hip usually has a little less odd movement, and so I like choosing the hip. So I'm going to right-click right in the middle of my hip marker. Actually, sorry, I'm going to pick my marker tool down here. So if I follow my line marker, pick my marker. That's going to go in my hip point there. Okay. And then what I'm going to do is I'm going to right-click on this. It's already given me where this is. I'm going to right-click. I don't want to display measure, so we don't need that. I'm going to right-click again, configure this. I actually like to have this red because it really stands out, so I'm going to choose red for that. And most importantly, I want to make sure that I'm right inside the marker I put in my subject, because I really need to be able to track this well. And again, I can't emphasize enough, when you're doing video analysis, good quality video and markers that stand out are the most important thing. And that's why we use red, white, and black markers, because usually one of those colors stands out really well from the subject's clothing or the subject's skin color. And that's why we use different ones. We use white here because it just stood out really well on this individual's knee and ankle. We used red on the shoe because their shoe was black and white, and so we needed another color. And we used red here on the shorts. We could have used white. We just chose red instead. Hopefully that will track pretty well. So again, I'm going to go back to my thing here. I've already hit start tracking, which I've done. So hit start tracking. And now we're just going to start to play through this. Now, this is going to go somewhat slow because of the frame rate, and I have this set at a kind of a slow speed. But as you'll start to see in a second, my subject's going to start to move. And I actually like the slow speed. This way I can make sure the tracking is working okay. And so I can kind of follow along, make sure this is tracking well with my video. And I'm pretty happy with this so far. This looks good. Our subject lands, they absorb the landing, and then they stand straight back up. I'm pretty okay with that. That's actually quite good. So we're going to hit pause. And then I'm going to go to my marker again. We're going to go stop tracking. And now at this point, I can actually look at this data. So I'm going to go to Tools, and we're going to do Linear Kinematics. And what we'll see, what appears on our screen, is a graph version of movement of our marker. Now, the default is speed. So this is actually the speed at which, over time, the marker was moving. Now, this is helpful, and if I want to know, for example, like speeds at different points, that's great. And if I want, what I can do, actually click on anywhere on this graph, anywhere on my line, and it'll tell me what that marker is. So maybe I want to know, hey, what's the maximum speed this marker moved at, right? Maybe that's a measure I want. I can click at the top here, and we have 6.34 meters per second, which is great. So speed, maybe that's something I want to know. Maybe I want to know the horizontal position, which, you know, in this test is not really helpful to us. Vertical position is helpful. Because if I want to measure the vertical jump, really what I want to know is how high did the hip go from its starting position. So if I wanted, I could say, well, the hip marker started at 27.7 centimeters. It got to its highest point of 79.23 centimeters. I could do a little math and figure out vertical jump. So this is pretty helpful. There's actually a better way to do that. I can go down to relative vertical displacement. And I actually like this better because what it's going to do, it is going to take the first frame as its reference position. And assuming the person didn't move a whole lot, and which they didn't when they were standing, if I just now click on the top of my curve, it has 51.3 centimeters, which is in reference to where it started, which was 0. So I can just take this curve, click on the top of that curve there, and I can tell the person's vertical jump, or how much the hip marker moved vertically, 51.46 centimeters. And again, really accurate depiction of that vertical jump. And again, we can do this over and over again, but that's pretty accurate. There's other data we can do here if we want to look at vertical velocity. If I want to look at acceleration in the vertical plane, that might be helpful to me. And so there's a lot of markers, a lot of measures here that may be of some value to me in regards to later data acquisition and specific things I want to know. Now, let's say I want to actually save this data. I want to know what all these different points are, right? So what I can do is I can go save the file, and I'm not going to do it in this because it'll open up a different screen, but I can save the file, and it'll allow me to save this data as a CSV file. And if you're not familiar with CSV files, they're comma-separated files. They're very useful in a lot of software programs to handle large amounts of data. So Microsoft Excel could open that, MATLAB could open that, other programs can now open this data, and I can look at it, I can make this graph, I can do some other calculations with that data if I see fit. So that's an option for me if I want to do that. Okay, so that's again is our linear kinematic analysis using Kinovea. I hope that helps, and we will see you in the next video.